Now let's look at the k-colorings problem. This is a natural graph problem that many of you have probably seen before, though I don't think we've looked at this particular problem in this course yet. You've probably heard of the four-color theorem. This is the formulation of the general problem. Now the input to the problem is an undirected graph G and an integer k. K is the number of colors in our palette. Now our goal is to assign colors to the vertices so the neighboring vertices have different colors. So if there is a proper coloring, we're going to output an assignment of colors to the vertices. So each vertex is going to get a color between 1 through k. These are the names of the colors. And this is a proper coloring if adjacent vertices get different colors. Now if this G has no such coloring, then we output no. So if there is a proper vertex k coloring for this graph G, then we output such a coloring. And if there is no such proper k coloring, then we output no. Now the k-colorings problem is in NP. Why? Well, first off, it's of the correct form. When there is a solution, when there is a proper coloring, we output such a coloring. And if there is no such coloring, then we simply output no. Now the non-trivial step is we have to show that we can verify solutions. So suppose that we're given a graph G and we're given a k coloring for this graph. So we're given an assignment of the vertices to each of the one of the k colors. Now how do we check that this coloring is a proper coloring? Well, we go through the edges of the graph and we check that each edge is not monochromatic. In particular, in order m time, which is the number of edges, we can check for every edge that the color assignment for V is different than the color assignment for W. So for every edge, the two endpoints have different colors. That's it. That's all we have to do to show that the k-colorings problem is in NP. We simply have to show an algorithm which can verify solutions in polynomial time. And it's a trivial algorithm, so it's a simply one-sentence proof that the k-colorings problem is in NP.